friends, my name is Nilesh. In this video, we are going to continue the 15 factor app series and we will look at the 12 factors apps or the remaining 2 factors of the 12 factor app. So far, we have covered 5 parts of this series and we have covered 10 different attributes or 10 different factors related to 15 factor apps. We are coming to the penultimate episode or penultimate video of this series where we'll be talking about the last 2 attributes of the 12 factor apps, and in the next video we will look at the 3 additional attributes which got added as part of the 15 factor apps. So let's get started and look at the logs and admin processes today. First one is the logs. The logs, as per the 12 factor apps, it says that we should treat logs as a stream of events. If you look at the enterprise applications, historically logs have played a very important part in debugging. Once the application is deployed to a target environment or production environments, usually the developers or the application team does not have access or direct access to the development or deployment environment or the production environments. And when an issue happens or when there is a problem, the logs play a very important role in terms of identifying a series of events what might have gone wrong. So since a long time, since I think decades, logs have been a very important part of the software ecosystem, and there are tools available in the market which do various things with logging. And there are companies and organizations which specialize in log management. So when it comes to logs, this 12 factor apps, they recommend to treat the logs as a stream of events, because in the past logs were stored on the disk. Let's say it could be a web server, so web server logs would be stored on the web server's disk. If it was a database server logs would be stored on the disk. And then we would also have the maintenance of these logs. So there were housekeeping jobs which would take care of retaining these logs for a period of time. It could be because of compliance reasons where companies had to maintain logs for, let's say, 3 years, 7 years, or 10 years, depending on the various regulations. And because of this, managing the logs is a key component or very important. Now, when it comes to cloud native applications, we cannot assume that there is a disk attached to the system. I talked about this in the first video where we saw that the thing around assuming that the disk would be there is a sort of an anti-pattern in terms of cloud native applications. These applications, they are supposed to be ephemeral. They can be moved from one host to the other. So if you assume that the logs are going to be always there, written to a particular folder or directory or file on one host, when we move the application from one host to the other, or when we want to scale the application from one instance to multiple instances, it will cause problems. If we, let's say, rehost the application, if we deploy the application to a cloud and the cloud provider decides to move the application from one server or one virtual machine to another, we would lose those logs which were written to the earlier host. So because of these kind of reasons, we cannot rely on logs being written to the disk and being stored on the same host as where the application is running. That is why what the 12 factor apps recommends is we treat the logs as a series of events and we treat it as a thing which is an infrastructure related feature, or it becomes a part of the roles and responsibilities of the cloud provider or the infrastructure team and not the application team. From the application team's perspective, all they have to do is they have to write the log entries to the standard output and standard error streams, which is in most cases the console. And then the aggregation, processing, storage, and the maintenance of these logs is taken care by the cloud provider or a system which is well suited for log management. In the past, there have been projects or tools like the Elasticstack, ELK, commonly known as the Elasticsearch, Logstash, and Kibana, which is used for the aggregation, collection, and visualization of logs. Over the period of time where cloud native applications became popular, the Logstash has been replaced by a more performant component called the Fluent Bit, and the rest of the stack, Elasticsearch and Kibana, they form part of the EFK stack now. If we are talking about a big data kind of system, then we can also store logs external to the application using tools like Splunk and writing it to a Hadoop file system, HDFS, and then using things like Hive to visualize those logs. There are also third-party products like Sumo Logic, which do this to a much better extent. So the whole idea here is for the application developers to assume that there would be some sort of a service or the feature available as part of the runtime environment or the deployment environment where the logs will be collected, they will be aggregated, and they will be processed separately. Application developer and application team has to focus on the application logic, and whatever logging they have to do, they do it to the standard output and standard error streams. In the screenshot above, I have shown a small example of one of the things which I did with the EFK stack with regards to Kubernetes. So I deployed an application containing RabbitMQ producer and RabbitMQ consumer service, and then this was deployed on the Azure Kubernetes Service or AKS, and we used the Fluent bit to collect logs from the Kubernetes pods and the services and the infrastructure layer, as well as the application logs from the RabbitMQ producer and the RabbitMQ consumer. And then Fluent bit shipped all these logs to Elasticsearch for long-term storage. And then we used Kibana to visualize those logs. So this is a common pattern nowadays with cloud-native applications where logging and the other telemetry information is treated as part of the cloud provider services. There are things like, if we talk about Microsoft Azure, there is the log analytics and there is log monitoring services, which can be used as part of the cloud provided services. If we don't want to have a lock-in with or a vendor lock-in with a cloud provider, we can use open source tools like FluentBit or Elasticsearch or any other product which works across the cloud. But the whole idea is, from an application point of view, treat logs as a stream of events and write them to a standard output and standard error streams, and let your cloud provider or your hosting environment take care of the aggregation, processing, and storage of logs. Moving on, the second attribute or the second factor that we are considering today is the admin processes. 12-factor app says that run admin or management processes as a one-off process or one-off task. Typically, the one-off task or the admin processes involve things like the database migrations, or it can be the periodic scripts which run as part of a daily, nightly, or monthly batch. It can also involve things like running a database script to fix some data issues. And when the 12-factor apps were advocating these admin processes, they built this mainly around things like languages which were having this REPL feature. REPL, or it stands for read, eval, print, and loop. It's a continuous process which typically uses this interpreted languages to perform an action and to query the status of the event or the system. So typically things like Ruby on Rails or Python, they have this shell which we can log into, and we can write these commands on the command line and we can get the response right over there. So with that in mind, admin processes were treated as same way like the application process. If we run these processes as a separate process, if let's say a database administrator logs into a application or a database client and runs the one-time script to fix the data, and if we have to do this in different environments, then sometimes we might lose track from a maintainability point of view, and it can also cause drift in the environments where the same script is run by the administrator, let's say only in production environment, but it is not run on the pre-production or staging environment. Then when we have to debug the issue, we might have these differences in the state of the system, which can be difficult to identify. So for that reason, 12-factor app says that these kind of one-off processes, they should follow the same kind of application packaging and deployment process, and we should run them as part of a normal application itself. So let's say the periodic script which runs for daily, nightly, and monthly. If someone logs in into the system and runs a command on a daily basis, or there is a cron job which is written to execute the script, it resides outside of the application process. So to avoid these kind of thing, we can make it as part of the application itself and run it as one-off process as part of the application. So we can package it as part of a feature of the application, and the application can itself run these processes. That was the thought process in the 12-factor apps. But with the advent of cloud and the way cloud operates, nowadays we have features like serverless functions, where we can perform these kind of operations using things like Azure Function or AWS Lambda. So let's take an example what we have seen here in the screenshot. Let's say there is a batch process which has to run on periodic basis. If we were to do this in the legacy way, we would deploy this batch process on a particular server, application server, or a web server, or it could be a database server, and then we would have to keep that server running all the time. Although the job runs maybe daily, nightly, or monthly, we still had to maintain that server running all the time. With the cloud, we are looking at optimizing the cost, and cloud provides us this way where we can define functions and we don't manage the infrastructure. The code executes on an event. So it could be a timer which kicks in this particular function. It could be AWS Lambda or Azure function, and then it executes the batch process. And once the processing is done, the function is terminated, and the resources used by those functions, they can be taken back. So that way we optimize the cost, and we don't have to keep maintaining this server for long period of time. And also the maintenance, the upgrades, the patching, all that is taken care by the cloud provider. So in current context, I feel that this admin processes factor is a sort of irrelevant, or even if it is relevant, the context in which it can be implemented, or the way in which it can be implemented in today's cloud native fashion, we can easily replace this with the serverless functions. So I hope that you found both these factors useful. And in terms of references, like I did for the earlier parts of this series, I always refer to this report by Kevin Hoffman in the O'Reilly for Beyond 12-Factor Apps. When it comes to the 15 factors, there are two GitHub repositories, one by Christopher Judd and one by Vikas Gupta. And there is also a Medium post by Vikas Gupta. And when it comes to the Java applications, cloud native Java applications, there is a post by Grace Jensen from IBM, which again talks about the 15-factor cloud native applications. So in summary, what we have done so far in these 6 parts is we have covered the 12 factors of the 12-factor app. And in the next one, which will be the last part of this series, we will talk about the new factors, the API first, telemetry, and authentication. Hopefully you found this useful, and you gain some knowledge about the cloud native applications and the 2 factors that we talked about today. Go ahead and hit this like button if you found the video useful, and also subscribe to the channel for future updates. Until next time, code with passion and strive for excellence. Thanks once again for watching this.